In this lesson, we're going to take a look at actually solving the system of equations using a matrix and not just setting it up. So let's go ahead and set it up first. We have a system here that we need to put into a matrix equation. So again, we always create the coefficient matrix first, and the coefficients are the numbers in front of our variables. We need to make sure that we put them in the same order. So a 5 and a 3 need to be in the same column, -4 and -2 in the other column. And then we write our variable matrix, x and y, and that equals our constant matrix of 4 and 3. Okay, again, to solve a matrix equation, we need to be able to get rid of this matrix. These two matrices are being multiplied. How do we get rid of the matrix here and move it to the other side? We can't divide, so we find an inverse matrix. So to find an inverse matrix, we need to find the determinant first. 5 times -2 is -10. 3 times -4 is -12, and we subtract these two. Minus a minus is a plus plus, and we get a +2. To find the to find the inverse, we take our determinant and put it over 1, and then we scramble up this matrix. We switch these two elements, a -2 and 5 we switch, and we change the sign of these two. This becomes a +4, and this becomes a -3. And then we go ahead and multiply our matrix here, and we finally have our inverse matrix. -2 times 1/2 is -1, 4 times 1/2 is 2, -3 times 1/2 is -3/2, and 5 times 1/2 is 5/2. Once we have our inverse matrix, we multiply both sides of our matrix equation by our inverse matrix. And remember, when we do that on the left-hand side, the coefficient matrix and the inverse matrix cancel each other out. I think the longest thing about these problems is the amount of time it takes to write them out. Okay, and remember, our inverse matrix always goes to the left of our coefficient matrix when we're going to multiply. So when we multiply these, we get the identity matrix, which pretty much tells us that it cancels, these two matrices cancel out. And all we're left with is one matrix multiplication to complete our job. So we have a 4 and we have a 3 to multiply, and we get x, y equals 4 times -1 is -4, 3 times 2 is a +6, so we'll add a 6. 4 times -3/2 is -12/2, which is a -6. 3 times 5/2 is 15/2. And all we have to do is simplify. And we get 2, and let's see, -12 and 15 is 3/2. So to check our answers, let's go ahead and plug in. Looks like x equals 2 and y equals 3/2. And let's go ahead and plug that into our equation just to make sure it works. So we get 5 times 2 minus 4 times 3/2 equals 4. We'll need to check that. And then we have 3 times 2 minus 2 times 3/2, and that should equal 3. So when we multiply this out, we get 10. We get a -12 over 2, which is a -6, and it does equal 4. And then when we multiply this out, we get a 6. When we multiply that out, we get a -6 over 2, which is a -3, and it does equal 3. So we definitely got the right answer for that. So now what I'd like you to do, oh, and I should say we always write it as an ordered pair because it is a system of equations. Now I'd like you to do the same thing and solve the system using a matrix equation.